Okay, this how-to video is going to cover the reflection analysis commands that's available inside of the Cadence PCB tools. So I would say here is to start off with, if you go to the Cadence support site, so support.cadence.com, and under the learning and the rapid adoption kits, if you just do a search for reflection, you'll actually find this Allegro integrated analysis checking reflection analysis. And this is kind of a workshop that you can work through, which will give you a good understanding of what actually happens with this command and this functionality and what license level you would need, etc. So it's worthwhile having kind of a look through this rack to kind of help you understand this. And if you get to the bottom of there is actually an option to download the zip file, which will give you a board file, some model files, and this PDF to kind of help you work your way through it. So we'll start off, if we look at the Analyze and Workflow Manager. We've got some different workflows here. In this example, this is the reflection workflow, so we're going to select the reflection workflow. So we've got some model set up to be that's required in this. This is all IBIS based. So if we look at some of the default IBIS models, you can see kind of some default Cadence ones here, some IBIS models here. We can browse and choose kind of different models that we want, so you can obviously see all the pin requirements have been defined in this specific IBIS model. If we look at manage libraries, we can browse to where we've got a specific library file. So this is give us an idea to kind of look for the list of libraries that we want and where we're going to use it from. So it's worthwhile having a look through the libraries. And then finally, there's a model manager that allows us to kind of choose specific model parts. This is kind of part of the Sigrity flow inside of the Cadence tools. And it allows you to kind of work through what you need to do from managing libraries and models, etc. So from a model assignment point of view, we're looking for a specific model in this example. So I need to find the part that I want to look at, which is this one here. Model's not found at the moment, so we can actually click on let's browse for a model. I want the IBIS model, and if I actually browse for the IBIS file, this file is actually provided as part of this rack, so we're okay there. The model then gets found for that specific part. So once we've got that, we can then start to look at choosing some nets. So what we'll do is we'll go and select the specific nets that we want, and in this example I want effectively 6, 7, 8, 9 and 10. So we're okay to that. Let's have a quick look at the analysis options. So this is effectively the default settings we can have. The only thing I'm really going to change here is the offset delay, but you've got different options for what you want to go and define for this specific net, and what reflection rules you want to specifically use for this design. Once we're happy with that, we'll click OK, and then we'll start the analysis. So depending on the license level, obviously you would need an Aurora based license at the moment to be able to run this simulation. If you haven't got that, you would have to get your SI engineer to run this simulation, and then you could effectively load the existing analysis that he would provide you, and then later then view this. So once we've got that, we can look at the reflection vision, which would obviously show you the reflection vision options. And the net's similar to the other analysis mode, so it's obviously taking over the colours of the screen. We've got different kind of focus data, so if you want to look at something like propagation delay, for example, we can see the actual propagation delays here, the receivers, the drivers, all the input parameters, the ringback margins, the overshoots, whatever you kind of want to look at from a reflection point of view. And then we can pick a specific propagation delay net, for example. So we'll just go and pick the net, and then we'll see the specific curve for that specific net in the simulation.